Hello everybody, this is Cameron Snow with Danomics.com. In this video series, we're going to be reviewing some Danomics decline curve analysis and forecasting capabilities. So let's get started. The first thing that you're going to want to do when you start working with Danomics is you're going to want to forecast out some production on a well-by-well basis. Doing this is quite easy, and there's a couple of different ways we can do it, and we're going to go over those in this brief video. First thing we need to do, though, is we need to pull our data in. So we're going to bring in our well header database as well as our production database. This is just public data that's been scraped from the state of Wyoming. And as you can see here, we have around 7,000 wells that are shown here on the map. And if we click to show our production bubbles, we can see our cumulative production for oil and gas showing up here. We notice that our well list has been populated as well as our map. And if I click on a well on the map, it brings up our production as well as our forecast here. And if I zoom in here on the forecast, we can zoom in a little bit here. Now, a couple of things. We can view this on log scale. We can also split the scales on these to give ourselves some separation. And we can also display the water in here. We'll come back to this in a moment. What I want to do first of all, though, is I don't want to work with 7,000 wells. I imagine you don't want to work with that many wells as either when you're doing an analysis. So what we're going to do is we're going to filter this down. First of all, I'm going to get rid of wells that don't have any production. And I only want to look at horizontal wells for this example. So I'm going to filter down the wells that have laterals that are greater than 5,000 feet, let's say. You probably only want to look at wells of a certain generation. So I'm going to look at wells, let's say, that were drilled after January 1st, 2010. And I want to filter by formation. So I only want to look at wells that were drilled in a unit labeled as the Niobrara here. Okay, so once we've done that, now down to around 245 wells in our well set. And when we click on when we click through some wells here, we can see that every well has already been declined out for us. So we'll just come through here and we'll click through some wells. Okay, so we now see that we filter down to a relevant data set and all our wells have been automatically declined. But when we're doing this, we probably want to have more control over our interpretation and how this is being done. So we're going to constrain our decline here. And when we think about the basic ARPS equation, there are three parameters that we need to think about. There's QI, that is the initial production rate. There is the DI, that's the initial decline, and then there's the B factor. So for our max QI, this is, how high do we want to let that QI go relative to our maximum observed rate? Now remember, we're looking at monthly production data here. And so, the maximum QI from our monthly production data may not correspond to that theoretical QI. So we want to let that go a bit higher. I'm going to set that constraint at a value of 2. For our min and max DI, I'm going to set that between a value of 0.1 and 50. Now note that in Danomics, we are not using this as a percent decline. And the range that I've set here will be somewhere between about let's say a 10% and 95% decline. So we're just setting some broad constraints for that initial decline. And then for my B factor, I'm going to set that to be between a value of 0 and let's say about 1.3. I don't really want to see my declines go above that. And once I've made this change and I go back through and I were to flip through these wells again, I would see that now everything is constrained within the values that I've put in here. Now, one thing you'll notice is, especially with some higher B factor wells, is we'll notice that the declines really flatten out with age. And we probably want to put a terminal decline on this. So we're going to put a terminal decline. I'm going to put that at about 8% per year. And you can see that our decline curve updates, our forecast updates here, and it's now labeled with the terminal decline period on there. All right, so now that we've done that, uh, we've constrained our analysis, we've put on a terminal decline, and once again, that's been applied to every well. So now we can see for each fluid where we reach that terminal decline rate for our minimum annual declines here. All right, so now we want to add one more layer of sophistication here. We want to add some economics. So Danomics allows you to apply some quick economics here, and these economics tie back in to the EURs that we're calculating, because we want to only produce economic volumes here. So I'm going to put in some general numbers here for our oil and gas price, our royalty, fixed and variable OPEXs. We can put some inflation on there, put our severance taxes in, and probably the most important parameter here is the well life. Do we want to let these wells run for 30, 40, 50 years? Up to you. All right, and now that we've done that, once again, all our wells have been updated. And if we zoom out here, we can see where we hit the economic cutoff on these wells as well now. So this is where we're hitting the economic lifespan of most of these wells based on the parameters that we're putting in here. And we can see that for some of these, that can be quite far out in the future. So approaching that 35, 40 year mark in this case. Now, we also want to do this. We want to include water in our analysis as well. So we're going to do this. All right, so you're thinking, all right, great, we're done. Every well's already been declined out. Well, let's not go crazy here. We want to, of course, customize our interpretation. So Danomics gives you the ability to come through and start with the automated decline, or to go through and apply a manual decline. So let's say I wanted to flip through my wells here, and I see, okay, I'm actually maybe not getting a great fit out here later in time. A few different ways that I can fix this. First of all, I can drag my start date out to start later in time. And this allows us to concentrate less on the early time data and more on the late time data. Now, if I want to get each of my fluid phases here, I can just hit the shift button and double click, and that puts the same start date for all of my fluid phases. Okay, and then once again, I can just click here in the well list and I can continue my interpretation. Okay, here maybe I'm not getting a great fit on the water phase. So what if I want to just change the water? Okay, well I could just come in and maybe type in a lower DI, a higher B factor, and we can affect that decline. Now, I'm going to move this farther out. So one of the things that happens in this data set is you get a lot of early water production in these wells due to flow back of the frac fluid that ends up getting reported. Okay, so that's something that we need to watch out for. And now that we've done this interpretation, there are a couple of other things that we can do. For example, we're going to want to QC this interpretation to make sure that we have a good fit here. And so what we're going to do is we're going to build a summary table, and I just need to hit the run button on here. And what this will do is this will start a summary job, and it will gather up all the QI, DI, and B factor data, and it'll do this for each fluid for every well, and we'll then use that for our QC. And now that that process is finished running, we see that we now have this populated table here of our QI, DI, and B factor. And let's take a closer look at some of these. So let's say I'm really interested in QCing some of my oil here. So I'm going to add a filter, and I'm going to say filter by fluid and oil. I'm going to hit add here. And I often find that the DI makes for a really interesting QC. So now let's click on a well, and what I can see is going on here is that we had some really high early time production, and we're maybe overfitting to that early time data. So I'm just going to pull this out, our start date out here, and update all our fluids for that. Come here, click on this next well. Once again, it's one of these scenarios where we see we have some early time data followed by a shut-in, and we're going to do the same thing here, update our declines. And once we've done that, we can just rerun this summary. Once again, this will just quickly update for us, and then we can continue our QC along these lines. And once we've gone through this and we've QC'd all our wells and we want to get the results out, Danomics makes this very easy for you. It's just File, Download Decline Curves, and this will download a summary spreadsheet for you in Excel. We also have the capabilities to export your declines to Aries to send those over to a map so you can map up your EURs, etc. And we're going to cover that in some of the subsequent videos. All right, I hope this was useful to you. Just as a reminder, what it is we covered in this video is we brought in our data, we filtered down to our relevant data set, we applied some general constraints, turned on our economics, and then we did some manual interpretation and QC on our wells. All right, if you'd like to learn more, you can reach out to us and contact us at sales@danomics.com. Thank you.